So here's our next problem. How many carbon dioxide molecules are in 0.500 moles of carbon dioxide? So here we're starting with moles of carbon dioxide. That's what's given to us, and we'd like to know how many molecules of carbon dioxide that is. So we can use this relationship right here, where 1 mole is equal to 6.02 times 10 to the 23rd molecules. First, we'll write the number from the problem, 0.500 moles of CO2. We'll put that on a line, and then we'll write a conversion factor using this equality that's going to get rid of moles and leave us with molecules. Since we want to get rid of moles, let's put moles in the bottom. We'll put our 1 mole down here, and we'll put our 6.02 times 10 to the 23rd molecules on the top. So we'll take 0.5, multiply it by 6.02 times 10 to the 23rd. Moles cancels, and we are left with molecules. And our answer here should be 3.01 times 10 to the 23rd, and it's going to be molecules. Remember that moles just counts a number of particles. It can be molecules that it counts, or it can be atoms that it counts. So let's look at our next problem. It's a little more complicated because it's asking us how many atoms of oxygen are in 0.150 moles of aspirin. And then they conveniently give us the formula for aspirin. We can see from the formula here that each aspirin molecule has 9 carbons, 8 hydrogens, and 4 oxygens. That's going to be important. This is our plan of attack. They've given us the number of moles. We have 0.15 moles of aspirin. We need to calculate first how many moles of oxygen that will give us. And once we have moles of oxygen, we can figure out how many atoms of oxygen we have. So here's our first equality. To make the first conversion, we'll need this information. 1 mole of aspirin contains 4 moles of oxygen. And we know that because of this little subscript 4 here. Each mole of aspirin is going to have 4 moles of oxygen. So we'll use this for our first conversion, for this first arrow. For the second conversion, we'll reuse this one here. For every 1 mole, we know we have 6.02 times 10 to the 23rd atoms. So, as we always do, we're going to start with the number in the problem, which is this up here. We're going to start with the 0.150 moles of aspirin, C9H8O4. I'm going to put that on a line. Kind of bobbled it a little. We're going to use this first conversion to get rid of our moles of aspirin and give ourselves moles of oxygen. So the moles of aspirin are going to need to go in the bottom. 1 mole of C9H8O4, that goes in the bottom, and 4 moles of oxygen go in the top. Okay, then we have another conversion. We need to get rid of our moles of oxygen and give ourselves atoms of oxygen. So this time we're going to put our moles in the bottom, and then we'll put our atoms in the top. 6.02 times 10 to the 23rd atoms, and this time it's of oxygen. So we're going to take 0.15 multiply times 4, multiply times 6.02 times 10 to the 23rd, and we will get 3.61 times 10 to the 23rd atoms of oxygen. And that's that.